All right, another way to display data is something called a box and whisker plot. So first we need to look at some definitions. We have something called a first quartile, which is the median of the lower half of the data. And then we have something called a second quartile, which is just the median itself. And then the third quartile is the median of the upper half of the data. We also have something called the interquartile range, which is when you take the third quartile and subtract the first quartile. It's a measure of variability from the center. How different are things from the median? And we use all that, we make this 5-number data summary so that we can make our box and whisker plot. So let's look at our data. We've been using these test scores and see if we can find all these pieces that we need. So if we divide it in half, the median of the lower half, we go to the middle, and the median of the lower half is 78. And the median we already found was 86 because we had to average those two middle ones. And then the third quartile, the median, the upper half is 92 because it's in the middle of that. So we can then use that to find our interquartile range and subtract that, and you get 14, which means that's how far things are varying. We aren't really going to use that number for our box and whisker plot, but we are going to use this 5-number data summary. So we put our minimum down, then our first quartile, then our median, third quartile, and then our maximum. And that helps us to do a box and whisker plot. So what a box and whisker plot is if we mark this off 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. These are all marked by 10s. Then we put a dot, 10, 20, 30, 40, 50, 60. 1 is about here. It doesn't matter how far up you go because we don't really have a Y value to plot. And that's our minimum, so we're going to put a little line there. And then at 78, so that's 60, 78, we're going to put a longer line. At 86, so 10, 20, 30, 40, 50, 60, 70, 86, we'll put that long line again. And then at 92, again the long line. At 97, we'll put a little short line. And what we do is between these 3 data points, we make a box, and then out to the minimum and out to the maximum are our whiskers. Now, you can actually do this on your calculator. If you put your data in list 1, where we had it before, and then go to stat plot, if you go to the first one and turn it on, if you see there in the middle of the bottom part there, it's a box and whisker plot. So you select that one, and you want your X list to be list 1. Then you're going to have to fix your window. Our window, we're going to put it from 0 to 100, and then because that's where the test scores could fall, you could start it at 60 if you wanted. That would be fine. And then the Y scale, we're just going to go from 0 to 10 because we don't actually have a Y value in there. But then we hit our graph button, and we have a box and whisker plot. And that shows us that there's more to this side, more values to this side of the median, or they go further from this side of the median than they do from this side of the median. The reason we use the median instead of the mean when we're looking at this, usually if we have something called outliers, which means data points that are really different, like if we had this list of test scores and one person made a 32, but most everybody else was up in the 70s and 80s, that 32 would be an outlier, and it would really affect the mean or the average. But the median, being the center value, it's not as affected by outliers. So if we have outliers, we're going to use the median and this kind of methods before we'll use the mean and the average.